Hi, you here?
Hello. Yeah, I'm Dr. Masha. Dr. Mazeen will join us later on.
Okay. Welcome to you. And what about Dr. Korhan?
Yeah, also he will join us later.
Okay.
Yeah, I'm here. How are
Okay.
you?
I'm fine, thank you.
Ria, are you there?
Yes, sir, I am.
Your voice is coming very low to us. It's not clearly audible. Hello.
Hello.
Yes. Now it's clear.
Yes.
Okay.
Sir, who is the volunteer here?
Ria.
Correct. Priority है 145. So please move कर. Sir, discuss. Session 2. एकांश session. Welcome, Professor Mustafa, our keynote speaker for our international workshop. Welcome, sir.
Sorry, my mic was off. Hello, everybody.
Hello, sir. Dr. Mazeen.
Hello, dear doctor. Hello, dear doctor. I hear you well.
Okay, Alhamdulillah. Thank you very much.
Good afternoon to everyone from India. I'm Dr. Ashish Khanna this side.
Good afternoon.
Good afternoon.
Dr. Salama Mustafa is with us. Mashil Mashi is there. Mazeen Mohammed Ji is here. Dr. MM Singh is also joined from Agartala, if I'm right.
Nearest usually Arunachal Pradesh, sir.
Arunachal Pradesh. I'm sorry, sir. I'm sorry.
Yes, sir.
But East India is correct.
Yes, sir.
I request Dr. Mazeen to introduce the organizer and the keynote of this workshop.
Deepak sir, I just want to interrupt you. I think Valentina ma'am has joined us. Welcome, Valentina ma'am. From Romania, I think. From Romania, Valentina Ibeles ma'am has joined us. I can see her in the meeting.
Dr. Kib, I will introduce the keynotes and the papers, authors, and behave of Dr. Mazeen. He's a little bit busy now, and he will join us later on. So we organize this issue between us.
Sure.
Okay. Ria, you can start, please. Ria. Ria, are you here?
Yes, sir, I am.
You can just start. Wait for 2-3 minutes more. Okay, it is 1:55 na, so you can start with 2 o'clock. Okay. And
Kindly wait for 2 o'clock because I've given the time of 2 o'clock to everyone. I think some more may will join.
Okay, sir.
Professor Valentina Balas, ma'am, are you here?
Kindly unmute yourself, ma'am. You have not unmuted. Valentina ma'am, if you can hear me, please unmute yourself. I think she has left now.
In the chat option, our workshop is.
No, she has again joined us. Yes, Valentina ma'am, how are you?
Professor Valentina, ma'am, do you able to unmute yourself? Okay, ma'am, I got your message on Messenger. I understand. Professor Valentina have login from his her PC, so he did not have microphone and camera. So she will join later today for our closing ceremony. Am I audible?
Yes, sir.
Hello, am I audible?
Yes, sir. You are audible.
Okay, okay, okay. Thank you. I think we can start. It is 2 p.m. Ria,
Yes, sir, I'll start.
you can start, please.
Okay. Am I audible?
Yes, yes, you are audible.
Okay. Welcome everyone to the International Conference on Innovating Computing and Communication 2021. Today's workshop will be on the topic Sustainable Heterogeneous Energy Aware Systems for Next Generation Devices and Networks. Let me introduce you to ICICC 2021. International Conference on Innovative Computing and Communication is organized with the objective of bringing together innovative scientists, professors, research scholars, students, and industrial experts in the field of computing and communication to a common forum. The primary goal of the conference is to promote the exchange of innovative scientific information between researchers, developers, engineers, students, and practitioners. Another goal is to promote the transformation of fundamental research into institutional and industrialized research and to convert applied exploration into real-time application. Overall, the conference will provide the researchers and attendees with prospects for national and international collaboration and networking among universities and institutions from India and abroad for promoting research. ICICC 2021 will be held at Shaheed Sukhdev College of Business Studies, University of Delhi, New Delhi. All the accepted papers after double-blinded peer review are published in Springer AISC series, and extended selected papers will be published in special issues of SCI, SCOPUS, WOS, DBLP, ACM index journals. Now, it's time to introduce everyone to the session chairs. First session chair is Dr. Mazeen Abed Mohammed. He completed his BSc degree in computer science from College of Computer, University of Anbar, Iraq in 2008. Master of IT from University Tenaga National, Malaysia 2011, and PhD from University Technical Malaysia, Melaka, Malaysia in 2018. He's currently working as a senior lecturer in Department of Information Systems in College of Computer Science and Information Technology, University of Anbar, Ramadi, Iraq. He teaches a variety of university courses in computer science, such as operating systems, database design, mobile system programming, software project management, web technologies, and software requirement and design. His areas of research interest includes artificial intelligence, medical image processing, machine learning, computer vision, computational intelligence, IoT, biomedical computing, bioinformatics, and fog computing. He has published more than 45 papers in international journals and conferences. Dr. Mohammed's outstanding scientific production spans over 45 plus contributions published in high standard ISI journals such as IEEE, Access, Future Generation Computing Systems, Medical Informatics, Computer and Electrical Engineering, Computational Science and Medical Systems. His publications are distributed as follows: 24 papers indexed in ISI's JCR and 21 papers indexed in SCOPUS. His Google Scholar citation reached 15 plus with H index 25 and I10 index 42. ORCID Google Scholar H index 27 of 76 papers. Scopus H index 21 of 58 papers. Publon's H index 17. Total citations 610 of 54 papers. I would like to invite Dr. Mohammed to speak a few words.
Actually, Dr. Muhammad, he can't join us.
Sorry, Dr. Mashal, I will be joined.
You hear? Okay, thank you. You arrived. Okay, thank you.
Firstly, good evening for everyone. Thanks a lot on behalf of our workshop organizers in Stability, Heterogeneous Energy Award System for Next Generation Device and Network. Actually, I would like to take this opportunity to thank everyone for your collaboration to succeed this workshop under your respect International Conference of Innovate Computing and Communication 2021. Actually, our workshop it's about a mobile system where utilize exclusively with the end goal of the voice call and overs, and we are made the enhance of the exhibition. Presently, the information management system have been tried to fundamental part of our mobile system. Our workshop, it's recommended many topics. The topics has been discussed in this workshop about adaptive system for wireless communication, for energy efficient location sense, for energy optimal scheduling, for power 2D techniques, for sustainable IoT frameworks, for agriculture system, for smart patient monitoring system, for heuristic algorithm, for activity-based data service, for energy predictive models and algorithms. Actually, we are focused about the blockchain technology, for artificial intelligence and information system, for machine learning and image processing applications, for optimization algorithms, for complex solutions. Actually, we have discussed deep learning for decision-making problems. Finally, for the deep learning approach for big data analytic and problems. Actually, our workshop have been include the following guest organizer, Dr. Korhan Sens, Associate Professor from Electrical and Electronic Engineering at Trakya University from Ardine, Turkey. Also, Dr. Mashal, Assistant Professor, Software Engineering Department, College of Computer and Information Sciences, King Saud University, Saudi Arabia. Thank you a lot.
Ria, you are mute. Kindly unmute yourself.
And I request all the speakers to kindly open your camera also.
Thank you, sir. I would now like to introduce you to our second chair, who is Dr. Korhan Cengiz, received his BS degree in Electronics and Communication Engineering from Kocaeli University, Kocaeli, Turkey in 2008. MS degree in Electronics and Communication Engineering from Namık Kemal University, Turkey in 2011, and the PhD degree in Electronics Engineering from Kadir Has University, Istanbul, Turkey in 2016. From 2009 to 2013, he was a research assistant at the Department of Telecommunications, Namık Kemal University. Since 2013, he has been a lecturer doctor with Electrical Electronics Engineering Departments, Trakya University, Edirne, Turkey. He is the author of over 20 articles. His research interests include wireless sensor networks, routing protocols, wireless communication, statistical signal processing, and spatial modulation. He is an editor of the Turkish Journal of Electrical Engineering and Computer Sciences. I would like to invite Dr. Korhan to speak a few words.
Sorry to inform you that Dr. Korhan, he MC, he has some special situations. He has emergency cases. So we'll be manage the workshop on behalf of him, me and Dr. Mashal.
Okay, Dr. Mazeen, thank you. Ria, you can introduce third session chair.
Okay, sir. Our third session chair is Dr. Michelle S. Mashi, received the BSc degree in Computer Science from King Abdulaziz University, KSA in 2005, the MSc degree in Computer Science from Glamorgan University, UK in 2009, and the PhD degree in Computer Science from University Nottingham, UK in 2014. She's currently working as an assistant professor in the Department of Software Engineering, College of Colleges of Computer and Information Sciences, King Saud University, KSA. She previously worked as an assistant professor in the Department of Computer Science at the Faculty of Computer Science and Information Technology, University of Tabuk. Her main research areas are evolutionary computation, multi-objective optimization, meta-heuristic, hyper-heuristic, software optimization, intelligent computing, and their application. I would like to invite Dr. Michelle to speak a few words.
Thank you very much, and welcome everyone. I would like thank you, Dr. Mazeen, also for leading the share of this session. As you know, this session is very important for the people who are interested in networking and devices. And now the new trend of technology is make some effective combination between different devices and networking in order to meet the needs of our generation, and we can adapt the advanced networking, so that this workshop will be so useful for the researcher around the world who are interested in this trend issue. And we welcoming our all speakers, and thank you for organize this conference.
Thank you, ma'am. Now, I would further like to invite our keynote speaker, Dr. Salma A. Mustafa. Salma A. Mustafa is currently the head of Center of Intelligent and Autonomous Systems at the Faculty of Computer Science and Information Technology, University Tun Hussein of Malaysia. He obtained his BSc in Computer Science from the University of Mosul, Iraq in 2003. He obtained his MSc in Information Technology from College of Graduate Studies, University Tenaga Nasional, Malaysia in 2011. He obtained his PhD in Information and Communication Technology from the College of Graduate Studies, Malaysia in 2016. He has produced more than 160 articles in journals, book chapters, conferences, and tutorials. His specialization and research interest include the areas of autonomous agent, human-computer collaborations, machine learning, optimization, and software quality assurance. Now, I would like to call Dr. Salma Mustafa to give a talk on his topic, Innovating Multi-Agent Systems for Reinforcing Intelligent and Autonomous Systems.
Ria sir has joined right now. Kindly invite once again.
I didn't get you, sir.
Sir has joined right now. I think he's not in the meeting when you invited him. Kindly invite him again.
Kindly repeat your words.
I would like to call Dr. Salma Mustafa to give a talk on his topic, Innovating Multi-Agent Systems for Reinforcing Intelligent and Autonomous Systems.
May I request Professor Mustafa to please start his keynote.
Actually, he is left now. I tried to call him again. Actually, I think, is there any interrupt in the internet connection?
I think he is on mute. He is listening us. I saw his photograph video.
Hello, Dr. Salama.
It is better if you can call him.
Yeah. I'm trying to call him.
Okay.
He said unmute his mic.
Okay. Ekansh, please unmute. Okay. Ekansh, are you here?
Sir, Deepak sir.
Yes.
Now he is.
I am here. Sorry for this issue.
Yeah. Welcome, sir. You can.
I cannot share.
Yeah. You are audible. Yeah.
Okay. Also, I have no permission to share my screen. Please allow me.
Okay. Sure. I will do.
See my presentation screen now?
Yes, it is visible now.
Yes, sir, visible.
Okay. Assalamu alaikum and good morning and good evening for people from other parts of the world, because now in Malaysia we are evening. Okay, so I am Salma Mustafa from Faculty of Computer Science and Information Technology. I am the head of the Center of Intelligent and Autonomous Systems, which is part of our university. I would like first to thank the organizers of the conference, ICICC 2021, and I am glad to be a part of this workshop. Also, I would like to thank Prof. Mazeen for inviting me to as a keynote. My keynote presentation is innovating multi-agent systems for reinforcing intelligent and autonomous systems. Actually, our center focus on developing different type of autonomous software. So we are not too much on hardware. We actually deal with software because we are computer science. And we try to apply different type of artificial intelligence, machine learning algorithms, and various existing systems in order to improve the performance of these systems. And one of the methods that we use is software agent and multi-agent system. I will briefly explain what is an agent in my keynote, and I will explain what is multi-agent systems, how agent and multi-agent systems are part of artificial intelligence, and what is the scope of agent and multi-agent system and artificial intelligence. Then I will try to explain several research opportunities and applications of agent and multi-agent system. So my presentation outlines our software agent and multi-agent systems. These are the basics. I will discuss the scope, concept, characteristics, architecture, community, programming, applications, then some research opportunities. Then if I have enough time, I can show demos of some of the software products that we produce in our center and in my previous research. So first, what is an agent? What is the scope of the agent? Actually, agent has two parts: software engineering part and artificial intelligence part. So it is mixed between two paradigms: software engineering and artificial intelligence. From the software engineering side, it is focused on how to improve and how to program and how to present and how to design software agents, similar to the object-oriented programming concept. So it is more concerned about fundamentals of programming of the agent. In my presentation, I will mainly focus on the AI side, artificial intelligence side, how the agent contribute to artificial intelligence. And it is more about the theory and the research aspect. As we can see in this figure, the root of software agent is artificial intelligence, and it is under distributed artificial intelligence. In distributed artificial intelligence, not only single technique is working. No, we have collection of techniques or algorithms are working together. Okay, so this is the distributed artificial intelligence. Each algorithm will be associated with a particular task or problem within a complete system. So similarly, we have multi-agent system. We have one agent that handle one particular task, and we have several agents working together and help each other to complete collection of tasks that refer to a top goal. Okay, so the ultimate work will focus on achieving the goal. First, if somebody is not from the AI field, what is an AI? Artificial intelligence. What is artificial intelligence? AI is a science that attempts to make computer do things that a human being can do. For example, the computer play chess, okay? We know that there are several algorithms that are able to even beat human players and these professional players, okay? Then under distributed artificial intelligence, I just want to give you example. You imagine why we need distributed artificial intelligence. Why not one single AI technique? Because if we have complex problems and distributed problems that cannot be solved by one single technique, we need a variety of techniques to work together. Actually, this is not available in any AI paradigm except some meta-heuristic algorithms, but they don't have the flexibility of multi-agent system, because agents can work together, interact, and flexibly contribute to specific environment, as we will see in the following slides. So what is an agent? What is an agent? One of the well-known definitions to software agent is made by Waldridge and Jenny in 1995. Actually, I like this definition because it has a clear context to what is software agent, and it looks at the agent theory in depth. Okay, so it is a computer system. We have a computer system, can be hardware or software, situated in an environment, exists in one environment. For example, a room, a hospital, a bus, airplane. All these are farm, okay, a school, university. All these are environments that is capable of flexible and autonomous action. This agent has the ability to do flexible action and autonomous action, and you focus on these two words, flexible and autonomous. These words differentiate the agent from other algorithms, other software, other theories, other techniques. It has these combinations, flexible and autonomous. Flexible means that this agent changes its behavior over time based on the environment condition and based on self-motivation. Okay, then autonomous, the agent has full authority to perform its actions. As long as we define these actions for the agent can choose among them the best choice based on its reasoning. So we have two types of agents. Actually, we have many types, but for autonomous behavior, maybe we have let me choose the laser point. Okay, for autonomous behavior, the main behaviors are the proactive and reactive behavior. The reactive behavior is the basic behavior of any program, which is response to change. We write our program and we put some conditions. If these conditions fulfill, our program will behave, will act, okay? So this is reactive behavior. As I will explain in the coming examples, I don't want to talk in details because it will take a long time to explain all these concepts and keywords. Okay, so the proactive behavior is more advanced behavior that artificial intelligence still attempt to fulfill. Okay, so the proactive behavior, the agent will take the initiative. When the agent has opportunity, it doesn't need to wait for human peer authority or others. It will take the initiative, take the opportunity, and do some actions based on its goals. Okay, so this figure shows a simple agent run cycle. So the first thing the agent will see is sensing the environment, will see its environment. And from sensing the environment, we need to have sensors. These sensors or inputs will come to the agent. If these data are not sufficient or not clear or not enough, it will affect the action. So we have to provide the best possible data for this agent in order for that agent to do correct actions. Okay. And this data will represent what the agent can perceive, what the agent can perceive, what the agent can understand. Okay, so whatever the agent observes, it will perceive. Then its perception will define its decision. Okay, so based on the agent observations, will make decisions. Actually, the decision are to decide on a course of actions. The decision is to decide on a course of actions. I will give several examples for how the agent will choose an action. I give you a simple example. If agent observe, let's say we have a agent that's responsible of a protection specific building, okay, or a police agent. So this agent observe a person attempt to enter a house. How the agent should react? Let's say this agent has 3 actions. Catch the thief or catch this pair, because under this scenario we didn't identify if this person is thief or maybe visitor. So the agent will first decide what type of person is this, must define this person. Is it a visitor or this person has some malicious actions that can be considered as threat, or a person attempt to rob the house. So based on the behaviors of that thief, maybe that thief attempt to climb up the wall and enter the house. So this is indication of this person is not represent a threat and might attempt to steal the house. So the agents have to decide again which type of actions should select for this situation. Call the police, catch the thief, or trigger alarm, for example. So which one is suitable? Is it call the police, or catch the thief, or trigger alarm? Actually, choosing the action should be based on perception. It is not arbitrary process. We have to decide based on our perception. Okay, so let's say if this thief is carrying a weapon. So based on this input, the agent might decide to call the police, because to try to catch this person, or trigger alarm. Okay, choosing trigger alarm or calling police, also it requires an reasoning level. So this is how the agent work based on perception, decision, and action. Okay. Okay, we talk about two types of behaviors for the agent, reactive and proactive. So the reactive agent represented by reactive architecture. The architecture describes how this agent works on its environment, what type of behaviors that the agent has. So the reactive architecture is a simple and practical. Actually, it is very old one and still working for simple systems. Okay. It's a problem. There is no reasoning or very limited reasoning, which make it weak in episodic or real-time environment. Okay, for static or semi-static environments, the reactive architecture or the reactive agent can be the best choice. Okay, when I say static or semi-static, means we have inputs, we have to make decisions, and these inputs are not dynamically changed. It is almost periodically changed with long period of time. Okay. So if you can see, all the architectures of reactive agent have cause, precondition, procedure, and action. Okay, these cause, precondition, procedure, and action. Okay, I give example of to explain this architecture, which is the air con example. In the air con example, we have compressor, we have thermostat and controller. Okay. So the thermostat of the remote control or in the air con is an agent, is a simple agent, simple reactive agent. And it should decide on temperature change. When the room temperature change to a certain degree, the thermostat controller gives a signal to the compressor of the air con. Okay, this signal is an autonomous action that okay, we already manufactured this air con and we set the temperature 24. So the compressor and the entire air con will work based on this temperature, when it is up, when it is down, and determine the controller of the air con determine the run state of the compressor. So in this scenario, what is the cause? We have cause, precondition, procedure, and action. What is the cause? The cause is temperature is high. When the temperature is high, this is the precondition. When the temperature is high, then switch on compressor. Okay. The procedure is the process of running the compressor. We might send certain voltage for signal telling to a certain switch to run the compressor. So another certain voltage will come to the compressor and run the aircon system. So what is the action? After the running the compressor, the temperature will go down. Okay, so this is the action, and the room will be cool again. Okay, this is an example of reactive architecture. It is very well known in robotics. Everybody in robotics must know this. It is subsumption architecture proposed by Rodney Brooks in 1981. So if we apply our scenario to this architecture content of sensors, behavior, arbiters, actuators, and actions. Okay, so these and this is the direction of the process. Okay, so our data is the temperature. Okay, so we have sensor to detect the temperature. Let's say this aircon unit responsible of the cooling system for 4 rooms. Okay, so to complicate the scenario, so for each room we need to have certain fans to flow the air. Okay, so the behavior is what? Is compressor on or off, or fan on or off? Okay, if we have complicated cooling system. Okay, so each one of these fans will be on based on the sensor data inputted to this cooling system. And arbiters are the rules. If temperature is high, then on compressor. If temperature is low, is off compressor. Very simple. And the actuators are the hardware, the compressor, and other actuators. Then the action will be we have cold air flowing to the rooms. Okay, the other architecture is proactive architecture. As you remember, we say proactive behavior. The agent has a reactive and proactive behavior. So this is the reactive architecture. Okay, and this architecture is a complex architecture. The agent has goal to achieve, so it is called goal directed. Goal directed. Okay, so the agent behaviors all connected with the goal. Okay, its attitude are programmed to achieve that goal. Its behaviors are motivated to achieve that goal. So we have in this architecture we have cause and effect, cause and we have a precondition and post-condition. And we have the procedure that will be triggered based on the precondition. It will run, then another condition, post-condition, to check if this action is satisfied or not. So that is by achieving particular goal or not, particular task or not. So we don't only act, we act and observe, perceive what we act. Okay, why? Because we are in continuous environment, we are in dynamic environment. So when we act, we know what happened to act again. Okay, so this is episodic or dynamic environment. We need to have a track of our actions in order to successfully perform in that environment. And for this type of agents architecture, I give this simple example. Let's say I want to, we have this robot. This robot wants to move an object from location A to location B. Okay, so the agent should act based on this architecture: cause, precondition, procedure, post-condition, effect, and action. So what is the the cause first? This robot needs to go to to carry an object from location A to and put in location B. Cause a command given by supervisor, by manager, by boss. So this is the cause. Agent got a command. Okay. So the precondition. What is the precondition of this scenario? Precondition. We have object. We have A location and B location. The precondition is the object in A. If the object not in A, this agent or this robot cannot do anything. Okay, because the first thing that this agent will do plan to go to that object in its location. The robot cannot go. The precondition, the object is in A. Then the condition, the object in B. So the procedure is how to move from A to B. This is an example of proactive agent with PSC architecture. I propose this architecture control small drone cluster. Okay, so it works on dynamic with dynamic environment. So the basic components is the planner scale controller. Okay, and this architecture can be applied in this scenario. We have so based on its observation, will tell the planner to plan how to. This architecture actually works based on belief design specific architecture of the agent. So the agent, the perceptions will be beliefs. So the agent believes that there is object in location A, will plan, and the plan will go to the scheduler because we have dynamic environment. We have scheduled action, non-scheduled action. They will be retrieved the box. They move to location B. Okay, assume that this robot observed this obstacle, the door obstacle. This is unscheduled action. Oh, sorry, unscheduled event. It is not part of the plan. The robot expect to see door. So that's why we need unscheduled action to deal with the unscheduled events. So now the robot, based on this observation, will replan again, and the actions that enable the robot to open the door. Okay, then proceed with the B, with going to location B. If this agent is not goal directed, will it drop the box, open the door, and go to B, and forget to carry the box again and move the box to location B. Because it is goal directed, the agent will knowing that the goal is the box in B. Okay, this is the issue. Now, what is multi-agent system? Multi-agent system are all agents working together to achieve particular goal. So before we have one agent, now we have agent community. 5 types of relationships that these agents have. Okay, they have communication, they interact with each other, share. They have cooperation, they help each other how to achieve certain tasks or parts of tasks. They coordinate their actions, okay? Let's say two robots carrying a table. So they call moving forward, left, right, the task or the mission is given will be impossibly achieved, okay? Then the agent might compete with each other. There are some certain cases that the agent, for example, if they are working in stock market, they want to compete and make the highest profits for their boss, okay? So this is called competition. And negotiation, agent will discuss, agree, disagree before they reach certain agreement. Okay, from the software engineering perspective, this is how software engineering people see agent, another programming language. So this is the evolution of programming concept. We have command-oriented, which is the basic one, the assembly language, then functional-oriented, C, Pascal, and others. We have object-oriented, C++, Java, and finally we have agent-oriented programming. As you can see, the agent is in the top of this paradigm. Okay, so why agent? Why agent? How is this agent different from object? Here are the differences. Agent adapt new behavior. Object, whatever program you make do. Agent can change its behavior. Then agent decide on carrying out tasks and pursuing action, while objects only executing tasks and actions. So the agent is more flexible and autonomous. Activeness. Inherit, we have multiple thread technology. You know what is a thread? A thread is a processing line of the CPU. So if the computer has some load, the agent work on multiple threads, and it has the ability to do or perform different type of tasks or actions in the same time. But the object not necessarily have multiple threads unless it is a program to do so. Interesting, agent do things because they want to. Agent do things for money, for making boss happy, for entertainment. Okay, based on the objectives that we want to program that agent based on it. While object do things because they have to. Okay, another slide of agent domain platform. We have mainly Java because Java is pure object oriented, and we have many platforms under Java. Developed on is Jack and Jade. Jade is Java agent development framework. Jack is multi-agent development framework. I actually use both, but I prefer the Jade because it enables me to program the agent that I want, more flexible. Then we have simulation tools like AnyLogic and NetLogic. They are different from programs because you don't need to know programming or Java programming. You just need to do some design and selection for particular actions and define these actions. Okay, application examples. We have applications examples, but the agent particularly good in distributed and dynamic type of applications. For example, remote sensing, because we have to have many devices to apply remote sensing, so each device can be controlled by an agent. Air traffic control. In air traffic control, we have many airplanes flying. Also, this is very dynamic and distributed, so agent work on this. Business process management, also stock market, we have many parameters that need to be analyzed and tracked. So also agents suitable. Also network, very many agent applications. Human assistant like robot or agent that will give recommendations or suggestions to agent. And finally, autonomous systems. Actually, these are examples. There are many others. Autonomous unmanned system or robotics. I mainly, actually, I work on agent in other parts, but this is my focus research, system and robotics. I don't know how much time left for me to proceed, but this is only to show some research.
Dr. Salama, if you can summarize your slide, we appreciate.
Okay, so the time is off, right? Can I show, continue? How much time I left for me, Dr. Mazeen?
Have from 5 to 6, 5 to 10 minutes.
Okay, so I will just go through these few slides. So these are the areas for agent that is still active and interesting. Emotion, so we want to put emotion in agents, so agent feel, show some emotional behaviors similar to human. Deliberation, the agent should have the ability to choose or think, has options, several options for particular, and choose among them, deliberate. And here we have two levels. Reason by itself, so deliberate its options, and try to deliberate with other agents to make better decisions, which is a multi-agent system. Then we have situational awareness, the ability to know his surrounding in the best way, because the agent observation is not free, it is likely that the agent will choose wrong action. Okay, so situation awareness is a research part that focus on collecting and integrating the best inputs, okay, for the agent. Then we have adjustable autonomy. This is also my field. We give the agent the full autonomy, but in certain situation we need to adjust that autonomy, and it is very demanding of every time this robot performs as we need, or sometimes we need to adjust the performance of these robots based on human preferences. Okay, I will allow the system to do certain actions for me. I will not allow the system to do other actions for me. So this is adjustable autonomy. And we have commitment. If I give the agent a task, how the agent should be committed to achieve this task. Okay, we have bold commitment. The agent must do, will not give up. Okay, must do the given task. And this type of agent is useful in static environment. We have the cautious agents that any change in the environment will change its mind and choose another action. And this type of agent is more suitable for dynamic environment. Attempt hybrid model between cautious and bold agent to be more flexible. So the agent in static environment will, in dynamic environment, will have flexibility to reconsider other options, maybe and do them and decide. I have collective intelligence. Actually, this is very part of research. whereby the agents are working in a particular problem, but they don't have solution. They have brainstorming, and from these fractions of solution and interactions, they complete solutions that all of them agree upon. Okay, these are samples of my research. I just will flash adjustable autonomous drone. When a drone work in dynamic environment and controlled by an agent or several agents. This is another project of elderly movement monitoring, whereby the agents will decide on the condition of the elderly. Is it the movement activities, walking, falling, lying, sitting? So from these combinations, the agent will decide on the following cases. Okay, to predict if this elderly have falling conditions. Okay, before the falling, and if there is a falling condition. Okay, then we have this project I make for MPOB, a very well-known company for oil palm, and it is about situational awareness for pest and disease. I also use multi-agent system. So the agents will track the pest and conditions in the estate of oil palm. Okay, then this is also another project about collective intelligence and multi-agent system. So the agent will try to solve the travel salesman problem individually or with collaboration. Okay, I have prepared actually demo for network routing optimization. I'm not sure time to show this demo. Thank you very much for your attention and listening. And if you have a question or discussion point, please you can ask.
Thanks a lot, Dr. Salama.
Thank you, sir. Moving on, it's time for the speakers to present their papers. Before we move on to the presentations, there are a few instructions. The speaker gets 10 minutes for presenting the paper and followed by 2 minutes of question and answer round. The papers will be reviewed by the chair and one of them will be selected by the chair itself. First off, we'll call the first presentation on the topic two-line defense ontology based trust management model. Paper ID is SHEASNGDN01. Please present your screen and you may start.
Urud, you can be start, please.
I think I have to stop my presentation first.
Urud? Urud, you can start your talk. I think Warud has muted the sound.
Dr. Mazeen.
Yes, Warud, you can start. You can start your presentation.
Okay. Hi, everyone. I'm Warud Al-Shaddud. I'm a C student in Department of Computer Engineering, University of Ferdowsi, Iran. Our title paper is a two-line defense ontology-based trust management model. I will talk about the abstract, then the introduction. So the literature review, then research gap of our research. So the methodology, then results of the methodology, then the conclusion and future work, then the references. So the for the abstract, heterogeneity, unvariability and dynamicity that are properties in dynamic distributed network. So adding the trust for this environment would enhance the security of this environment. Our approach is based on two defense line to protect the resources. The first line KNN, for the first line KNN, and the two line represented by the ontology. So an ontology defines the terms used to describe the object properties and data properties for the ontology. So the trust management means the degree of confidence for two entity or more. The semantic web enables the distribution and the exchange the information and the knowledge. So for the literature review, our approach based on 5 articles. Each articles based on the different approaches. Some of this approach is not suitable with the dynamic systems, and another is weak in a comparison with the trust management. For the research gap, the trust management is an important matter in the security, so it has a great attention in security infrastructure in last years. Excuse me. Also, in previous research, there are several proposed approaches that address the need for the strong trust management models to suitable for the dynamic aspects with the distributed networks. Our proposed methodology is based on KNN algorithm and trust management ontology. For the KNN algorithm, for the classification, the devices about trusted or not trusted, and the two lines, it's represented by trust management ontology for classification. So the output of KNN, it is fed into the inner line, which represented by semantic ontology to classify. So moreover, strengthened access to the protected resource according to the semantic information technologies. When we have the query about the user and the device of this user, we got the result is as shown in figure. According to our sample, the resources could to infer the semantic information. So this figure or this table belongs to the devices and the user of these devices according the contextual information of the devices and the users. So in this chart represent the time and the axioms of the ontology. For the comparing, our approach is suitable for the dynamic distributed network since the semantic information is updating. The first line represented by machine learning techniques is basically used to filtration, and the two line of defense represented by ontology or semantic web technologies. So the disadvantage of our work, high theoretical complexity, represented by exponential time of n. Conclusion on future work. Semantic-based techniques mixed with the machine learning methods. So we represent or show the capability of semantic-based technologies in building security system. So our approach can be used in conjunction with any novelty or any state-of-art authenticate paradigm. So for future work, we are planning to add the third line of protection is represented by the authorization for the ontology. Thank you very much for good listening.
If there are any questions, they can be asked now.
Thank you a lot, Wuruj.
Excuse me?
Thank you a lot for your research work.
Yes, excuse me. As you like.
Is there any question? I think we can moving with the second paper.
Okay. Before that, the keynote speech has started in the main meeting, so you can join there, whoever wants to. And we'll move forward with the second one. The topic is a machine learning based data fusion model for online traffic violation analysis. Paper ID SHEASNGDN02.
Yes, it is me.
Yes.
You can see my presentation screen.
Yes, sir.
Okay. I just want to switch on my camera. I don't know why I cannot. Okay. 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 Hello again. I am Salma Mustafa. Okay, this paper actually is about a machine learning based data fusion model for online traffic violation analysis. And in this paper, we are a group of researchers from University of Hussein Malaysia. Me, Dr. Aida, Dr. Azizul Azhar, Muhammad Farhan, Dr. Muhammad Farhan, and Mr. David Lim and Ms. Shafiza. So in this project, we attempt to use machine learning to predict traffic violation, and we use the software engineering. Okay, so a simple introduction about data fusion and traffic violation. As you can, as all of us notice, that there are some drivers that have bad driving attitudes. Okay, this driving attitude might cause different type of accidents. Okay, or making people drive uncomfortably. Okay, so it is considered as a traffic offense and it violates the law. Examples we have running red lights, speeding, reckless driver, drinking during driving or drunk drivers, or many other type of offenses. Okay, so the law enforcement of officials take action. They will issue summon or fine for this type of traffic violations. And most importantly, these violations might cause accident and expose others to danger. So nowadays, these violations consider notably public concern. When people see these type of drivers, they even report to the authority by themselves, okay? Because they know this behavior is make risk for the entire society. Okay, so what we are trying to do is we have data set with different violation, with different attributes for violation behaviors and normal behavior. So we want to create a model that can predict the violation cases from from these attributes or features. So our research methodology is very simple. We have data set, we do pre-processing, classification, two levels of classification, then evaluation, then we discover a new knowledge from the pattern of the raw data. The algorithms that we use from machine learning side, we use gradient post tree and naive Bayes and random forest. Okay, these are well-known algorithms and selected for a specific reason for each of them because they have different properties. Each one will have different properties. Okay, traffic violation data set. This is the data set we use in our work. It has 35 attributes that describe the traffic violation attributes. Is this behavior considered violation or non-violation? And these include the place description, location, vehicle type, year, make, model, violation type, driver gender, and etc. Then the classification classes are divided to 4 actually. One of them normally driving. Then the other one, we have warning, we have citation, and ESER. Oh, so based on the driver behavior, we can, or attributes, we will predict one of these 3 classes. Okay. Then evaluation criteria, we use accuracy, precision, recall, and F-measure. This is our proposed model. It has 3 main processing phases. We have pre-processing, classification, data fusion. In the pre-processing, we prepare our data in 3-fold cross-validation. This is one of the data mining or machine learning methodologies of data preparation for testing. Then we have our classifiers in training and testing steps. So we have GPT, we have NV, and random forest for the training and testing. After the training, the training will be on 3 folds. So 2 folds will be for training, and 1 fold will be for testing. And model to collect the evaluation results. Okay, so we have evaluation result for each algorithm. Then we have, in this part, we have data fusion algorithm, which work based on software agent, the one that I just explained in my keynote. Okay, so these algorithms will provide some results, and this agent try to fuse the result in one output. Okay, so if 2 of these algorithms select particular class, which is, let's say, normally driving, no violation, and one of them will consider it violation, so the majority will go to the 2 classifiers, as you will see in this figure. So this have overview. This figure show overview of how the algorithms work. We have 3 algorithms. They run. We have input pattern. From the input pattern, they either decide normal case or the 3 other cases. So either we have a normal case of driving or violation. If we have violation, we have 3 cases of violation. And here we have the data fusion algorithm will pick all the output of the 3 algorithms and process them and generate one output. Implementation, we use Java machine learning for implementing the machine learning algorithm. And our model, we call it MLDF, machine learning data fusion model. Okay. Then we use Jade to implement the agents, the software agent. Testing, as I mentioned, we have a 3-fold cross-validation to measure, evaluate the performance of these 4. Okay. The hardware specifications, as mentioned in here. Okay, the performance result, as you can see, if we look at the accuracy, the MLDF achieved a slightly improved accuracy over the rest, not too much, because in the end of the day, this result comes from these algorithms. So because they have almost near results, except NIBICE, so the improvement will be not significant. Okay, so this means that there is a big agreement between these algorithms. If there is no agreement, this MLDF should provide more better results. Okay, so which one is the best algorithm despite the MLDF? We found that GBT produced the highest accuracy, followed by RF, random forest, and naive Bayes. And our model actually achieves the best result and outperforms all the three, which achieve our objective. Also, you can see other criteria like precision recall as measures. We have the same results. And this figure visualize the table. And as you can see also, most of the MLDF performance matrices are higher than the rest. And also we have the very stable result. This represents the standard deviation of the result. And as you can see in the accuracy, the difference in the output within 3 floats is very minor, which means that MLDF is more stable model than the other 3. Okay, in conclusion, this research proposed a method that can give the best performance to detect traffic violations. It consists of machine learning and agent. The machine learning algorithms are GBT, NB, and RF. And software agent is simple reactive agent architecture. It is used to accumulate traffic analysis decision of the 3 algorithms. And the result shows that our model achieves higher accuracy, higher precision, higher recall, and higher F measures than the other 3 benchmark models. The future work, we attempt to apply feature selection algorithm to improve the features of the dataset in order to achieve higher performance. Thank you very much, and I am open to your questions.
Is there any question?
Dr. Mazeen, you can ask. This is your specialization.
Actually, I already evaluated your research work, and it's valuable.
Thank you, Dr. Mazeen.
So I would like to know if you are benchmark your work with other studies in the state of the arts.
Actually, I did a comparison, simple one with the related work, and as I can see, this data set is difficult because I didn't see any high accuracy. We might do one project together later to propose something that can achieve higher accuracy than whatever exists in the literature.
Actually, I seen from your experimental result, the 3 machine learning techniques have been achieved a good result. Do you have any suggestions if you use LTSM deep learning model to compare between the deep learning and machine learning?
Actually, I hide this future work because I want to do. So I want to combine the GBT with deep learning algorithm because I want to do multi versions of GBT in one CNN or any other type of deep learning.
Actually, I suggest, Doctor, if you use another data set, it will be more valuable.
Oh, why? What is wrong with this data set?
It's okay, but if you want to apply different machine learning or deep learning, you need to make a big data set. This is the suggestion.
Oh, okay. Thank
you
very much.
Is there any suggestion?
Any question from the floor?
Thank you, Dr. Salama.
Welcome, Dr. Mazeen.
Okay, moving on, we have our third speaker who is talking on the topic review of IoT for COVID-19 detection and classification. So you may present your screen and start.
Prof. Bilal Al-Khatib.
Hello.
Yes, Prof. Welcome.
Hello. Welcome. Can everybody see my screen?
Yes.
Hello. Can everybody see my screen?
Yes.
Yes, Prof.
Thank you so much. First of all, I would like to thank the organizers, the workshop organizers, and the conference organizers for accepting our work. Our work title is a review of IoT for COVID-19 detection and classification. A group of researchers from University of Ambar, and I will present the talk on behalf of Ambar, Iraq. So this is the outline of the talk. Actually, as everyone knows about COVID-19, it affects people's life in many aspects, in their health, in their economic crisis, and in their social life as well. So dealing with COVID-19 and using IT techniques in the detection of COVID-19 maybe in the prevention of COVID-19 will be a good help for the doctors and view for research that are proposed to use IoT in order for detecting and classifying and maybe preventing COVID-19. So as I said early, COVID-19 affects people in many aspects of their life, economy, and also the social life. So the lockdown policy restricted the movement of people, and scientists, including IT scientists, tried to detect and classify COVID-19 by using many ways. And this paper will try to focus on the research that used IoT for COVID-19 classification. COVID-19 is not the first virus that can affect people. Actually, in the last 2 decades, we have SARS, MERS, and Ebola, and lastly, COVID-19. So dealing with them in the IT point of view will be different, because in the IT will focus on how to detect COVID-19 and possibly how to prevent the spreading of the virus and many other things. So many researchers tried to employ IoT in order to achieve this point. Actually, the IoT in brief is just an interconnection of physical devices with the internet. The devices are not only sense and record, but can also monitor and respond. This is the most important thing in IoT, the monitoring thing and the responding to the various criteria. So the research question in IoT itself is how to improve or optimize the communication regarding the messaging and the speed, size, and performance, and how to minimize the latency for optimal user experiences. This topic, the IoT can also be adopted to classify the COVID-19 in many different ways. Actually, in the literatures, when we are surveying the literatures, all of them are recent, and we found that many researchers use the frameworks with machine learning in order to track and detect COVID-19. Also, they employed drone-based and wearable watch, sensors, robotics. All of them are used as IoT-based in order to detect the COVID-19 and detect and classify also COVID-19. And some of the research used blockchain, big data AI and big data, smart gadgets. So what is briefly what is done, some of the researchers used, for example, wearable watch. So this watch can be used by the patient, and there is a monitoring system that can monitor their movement in order to prevent the spread of the virus. Also, in order to detect whether the person have a COVID-19 symptoms or have an uninsured COVID-19 case. So all of them are used and employed to cover this, to cover the detection of the COVID-19. As you can see in the slides, for example, the first work used a framework system with machine learning, 8 machine learning algorithms. 5 of them achieved the accuracy of more than 90%. So drone-based also used. And we have a diagnosing, we have a robotic, smart age monitoring system. Also, some of the research used face detection, because in order to, for example, detecting if the person wearing a mask or not, or the symptoms appeared or not. And some of the IoT research focused on measuring the social distancing between the people, and all of this stuff that we know about how to avoid the spreading of COVID-19. As a conclusion, we think that IoT-based COVID-19 detection allow a more secure and informed environment to restart the new normal life. Also, a significant number of patients can be served using the IoT via cloud-based administrations and offices. The most important thing that we think that IoT can be used to prevent the suppression of the spreading of the virus itself, rather than the classification and all these stuffs. So as a future direction, we suggest researchers to focus on how to use IoT or employing IoT in order to prevent the spreading of the virus, and this can be done, and this can be significantly reduce the dangers of the virus suppression. Thank you for all your listening, and I'm ready for questions.
Thanks a lot to Prof. Al-Khatib. Is there any question? Dear Prof, may we know how many papers that you are reviewed in your study or your research work?
Actually, in this review, we have about 26 papers reviewed. All of them are published in 2020.
Okay. So most of them on the AI, on the classification task, or on the IoT applications in the COVID detection?
Actually, all of them are employing IoT for the COVID-19 detection.
Okay, thank you.
Thank you.
Okay, now we have the speaker who's going to speak on the topic on implementing and placement of hybrid beamforming for single and multiple users in the massive MIMO wave systems. The paper ID is SHEASNGDN04.
Hello, can you hear me?
Yes, sir.
Yes, Dr. Mustafa, you can.
Okay,
Start.
I will share my desktop now. I just want to make sure that my screen is in front of you now. You can see my slides.
Yes, sir.
Okay. First of all, thank you very much for having me here, and I'm very happy to be part of this conference. Our work that I will talk about today is about implementing and the placement of hybrid beamforming for single and multiple users in the massive MIMO millimeter wave systems for the 5G and beyond. This work has been done by me and my advisor, Dr. Husheng Li, when I was still a PhD student in the University of Tennessee, Knoxville, in the United States of America last year, and with the cooperation of with my colleagues, Dr. Ahmed and Dr. Luqman and Dr. Mazeen. First of all, I will talk about the motivation for this work. Then I will talk about the introduction, and then some of the works that we talked about. And as you will see, this work is part of like a bigger work to optimize the placement and location and implementation of hybrid beamforming, which is considered like an essential part for 5G and beyond systems, especially the systems that use millimeter waves, as we will see. Then we will talk a little about the simulation results, and then we will finish with conclusions and some future works. So the motivation for beamforming for millimeter waves or the higher frequencies in general is that whether it is millimeter wave or terahertz or like higher frequencies, is that they are suffering from huge atmospheric absorption. They have a weak reflection from most surfaces, and they have a huge path loss. So they, in general, they don't travel well for a longer distances, which means that we will need to install a lot of base stations, a lot of micro and nano cells. So instead of that, we can use the beamforming to direct our transmission from the base stations towards the mobile equipments or user equipments while they are moving, for the walking, running, biking, driving a car, or anywhere users. The beamforming will be able to make sure that we will send like narrow beams towards the user equipments instead of having the omnidirectional traditional way of sending and receiving wireless signals. So first of all, we knew that the beamforming has been studied for many years now, and there are a lot of types of beamforming, but one of them that is considered like the typical solution now is the hybrid beamforming, which is considered of the digital baseband and the analog RF chains, where it can have the good compromise between the cost and performance. It is cheaper than the fully digital beamforming, and it is better performance than the analog beamforming. So traditionally, the hardware-based beamforming has been studied hugely or largely in the literature for many years now. Some new trend about the beamforming and how to build beamforming functionality is to use the machine learning and deep learning and to deploy that on-premise or in the cloud or in the fog computing or cloud computing, any one of them. There is some kind of compromise. The on-premise hardware is usually limited by the space and the power consumption, heat emission, and all of these things. So we cannot put huge, massive MIMO system only on-premise. So some new suggestions suggest that we can transfer part of this functionality to the fog computing or to the mobile edge computing or even to the cloud core computing. So in our work, we tried to figure out what is the best place for putting the beamforming to make sure that it can track the mobile users for the normal speeds of like running, biking, or even driving a car. So the first part of our work is to optimize the work that has been done by Dr. Ahmed Al-Khatib, which is about the deep learning-based hybrid beamforming. That was studied for several years now, since he was working with Facebook, and then he joined the academia after that, and he has been working on this deep MIMO dataset, how to collect the channel information and use it then for deep learning based hybrid beamforming. So we tried to optimize his work and his colleagues' work by using different optimizers. Then we tried to use more than 16 channel training pilots, because he suggested in his last work that we can use only 16 channel training pilots, and we will get higher accuracy beamforming. Then finally we got gave some insights and some suggestions to generalize this work for multiple users instead of only single user. This figure here, as you can see, is part of the work that they implemented of just using the channel encoder, which is implemented or is representing the analog RF circuit, and then the digital precoder, which implements the digital baseband precoder. Both of them are just using the vectorized channel input or the collected channel data using the DeepMIMO dataset, then uses the compressive sensing for the channel, and then the hybrid beam prediction. And they got like a lot of good accuracy, and we will show that using different optimizer and different number of channel pilots, we will get even better results. For the other part of our work, we studied the delay that is involved in placing the hybrid beamforming other than the on-premise. So it is not just in the base station. If we put it in the mobile edge computing or in the cloud computing, or like whether it is a dedicated or shared cloud core, what kind of delay that will be involved, and whether we will be able to use the like this kind of architecture for good beamforming, because we know that for the delay it should be less than the coherence time always, because if it is more than coherence time, then the readings or the weights of the digital part and the analog part will be outdated, and it will not be able to track the mobility of users. So for the static users, we know that the beamforming can be placed anywhere, because there is no problem. Once we detect the location of the user, then we can just send the signal towards that direction for all the time of the call. But for the mobile users, the beamforming delay should be less than the coherence time. So now we are either putting the beamforming totally on premise, or we just put part of it in the cloud or dedicated core, shared core. And in each way, we can calculate the total delay, which will be the processing time in the base station, and then the round trip time between the base station and the core, whether it is like a dedicated or shared, as we said, in the cloud. And then the processing in the core, which is usually done by machine learning and deep learning algorithms. This is some like a realistic example of how each sector of the base station is tracking the mobility or the movement of each base station, and try to direct the beamforming towards them. And this is has been taken from like real installations of 5G systems that is using the beamforming. Of course, this is only for few users and only few number of MIMO antennas. If it is larger, the things will be even more complicated. So instead of having all the functionality within the base station, we are trying to see what is the best place for it, to reduce the cost and to increase the efficiency, while keep the beamforming working well. This is also like a figure from this paper, also from Dr. Ahmed Al-Khatib, where he suggested that we can use a central or cloud processing unit designed for the central beamforming, and it will train several base stations using neural network model. And as we said, this is like a new trend in the design of the beamforming, and we are trying to make sure that it can work. For the simulation of our system, these are the system parameters that we used for the realistic implementation of the beamforming in like a dedicated cloud core and a shared core. For the first part of our work, we saw that when we used the Adam optimizer instead of Adam optimizer that was used by the previous work, we could get better beamforming accuracy for the transmitter and the receiver for the TX and RX. And we also saw that if we use more than the 16 channel pilot signals or channel training signals, the accuracy, instead of going higher, it will go lower, which is like a huge limitation of this type of work. And this gives us like an indication of that, okay, we can make the best at the 16 channel pilot. But what happens after that? We still can't get higher than the 90%, which might suggest that we can go back to the traditional beamforming techniques instead of the deep learning, machine learning. This is like the discussion of this first part that we talked about. Also, we tried several multipath fading, and we collected 3, 4, or 5, and we saw that there is no big difference between, no real effect on the accuracy, which suggests that we can use only 3 multipath, or like 3 rays in each cluster. For the second part, also, we tried to send data and receive the response from the dedicated core network and the cloud core network. And we saw the delay that was involved in this operation. And we can see that the delay for the dedicated core is normally is stable. It is normally less than 42 milliseconds. Whereas for the cloud core, where it is like software-based core, we see that at first there is a huge delay involved because it involves calling and training a machine learning or deep learning signal network. And then after that, the response will go down because now we are using just a trained network or a trained model, and we can get better results after that. So at first, we can see that the cloud core takes a lot of time, a lot of delay, but after that, it can get as close as possible to the dedicated core. So we can see that like the benefits of this kind of architecture for the future. And either way, like whether it is 42 millisecond or whether it is 70 millisecond, both of them are way more than the coherence time of the millimeter waves, which is, for example, for the 28 gigahertz, it is about 600 microsecond. So it is way more, less than that. So we still need to work and get the beamforming closer, whether it is in the mobile edge computing or the fog computing, which will be part of our future work, hopefully, to find the optimal place for the beamforming to get the best compromise between the cost and the performance. Finally, for the conclusion and the future work, we studied the issue of beamforming and placement. The direct hybrid beamforming has been studied and optimized. The results recommend that keeping the beamforming as close as possible to the local network to handle the user mobility and the fast changing wireless channel conditions. For the future work, as we said, we will calculate the best place for the beamforming to take into consideration the expected number of users, the channel randomness, and the type of applications that we are working on, and even the beamforming architecture itself, whether it is like a traditional architecture or the deep learning, machine learning based architecture. That's all of my talk, and I will be happy to receive any questions. Thank you so much.
Thank you, Dr. Mustafa. Is there any question?
May I ask a question?
Sure.
This is Dr. Jamal Rasool from University of Technology, Iraq, Baghdad. Dr. Mustafa, it is a great job.
Yes.
And I wonder if can you tell me the distance which we can speak about it through this beamforming? First question. Second question, if we have many subscribers, the situation will be difficult. What will be the difference between 1 or 2 subscribers and many subscribers? Third question, what about the handoff? Thank you.
Thank you so much. These are great questions. Okay, so for the first question about the distance, until recently, the perfect distance for coverage for beamforming, especially for millimeter waves, was in the range of 100 to 150 to 200 meters from the base station to the user equipments. But now with like more advanced techniques, it can cover even up to 1 or 2 kilometers. So the radius of the coverage of each base station or tower can cover up to 1 or 2 kilometers in all directions, based on the number of sectors installed around it. For the number of users, of course, yes, we are talking about 1, 2, 3 number of users, and we can train the network based on that. If the number of users will be higher, of course, we need more channel realizations or channel data to train the network based on. And this include taking a lot of time, whether it is on-premise or in the cloud, which is something that also, as we said, we are still working on it, and we are aiming to find the better solution for the future to reduce the delay while serving more number of students, number of user equipments. Is that the question, or is there any other question?
Handoff. What about the handoff?
About the handoff. Yes. Of course, the handoff will be like a big problem. And one of the solutions suggested for that is that instead of having each base station or the sector of base station serving the users alone, these base stations should be all connected to the central or central processing unit or cloud processing unit, which collect the channel realizations or the data of all users from all sectors in one system, so it can make sure of a smooth transition or smooth handoff between the base stations and the sectors in each base station. So it will also be cloud-based, hopefully.
Thank you very much. It's a great job, really. Thank you.
Thank you so much. Thank you.
Thanks a lot, Dr. Jamal, for your kind question.
You are welcome.
Okay, so next we have the presentation on the topic neural network-based windowing scheme to maximize the PSD for 5G and beyond. So you can continue with the presentation.
Okay, thank you so much. I will share my screen now, and I will go directly to the other paper. I just want to make sure that the paper is presented in front of you now.
Yes, sir.
Okay, so hello everyone. This is Mustafa Al-Jumaili, of course, and this work is about a neural network-based windowing scheme to maximize the power spectral density for the 5G and beyond systems. This work has been done by my colleague, Dr. Ahmed Hamoudi, with his advisor, Dr. Luqman Oda, with my help and other collaborators. This work first we will talk about the index, the abstract, the introduction, the literature review. Then we will talk about the proposed methodology and the results and discussion, and we will finish with some conclusions and the future work, and of course some references. So in our work here, we are trying to design a new waveform for the 5G and beyond systems, and we saw that in the recent years, the windowing and filtering based OFDM based waveforms has been considered the new trend in the waveform design for the 5G and beyond systems. So because we are using the filtering and windowing because of the limitations and difficulties of using or achieving better spectral efficiency using the OFDM only based waveforms. So in the first part of this work, we will try to use several neural networks to detect the best window out of the list of 19 windows to achieve the required power spectral density, taking in consideration the acceptable adjacent channel leakage ratio. We saw that using the neural network, we can detect the best window out of a list of many windows with a high accuracy and with error rate in the order of 10 to the -7. And the second part of the work is when we will try to figure out the power spectral density and the bit error rate of the selected window from the first part. And also we are taking the universal filter multi-carrier system in consideration in our calculations, and we compare the results of our windowing system with the other well-known waveform designs. First of all, as we mentioned, the OFDM based waveforms are suffering from a lot of restrictions. So we are trying to avoid these restrictions and get rid of them by designing new waveforms for the 5G and beyond and now the talk is already about 6G, to increase the power spectral density and the spectral efficiency of the utilized bandwidth of these waveforms. A lot of work has been done using like the universal filter multi-carrier, filter-based multi-carrier, and other windowing and filtering designs. And we will try to design a new waveform and compare with these well-known designs and make sure that our work is superior over them. For the literature review, we reviewed a lot of work, as we mentioned in the recent years, about the filter-based and windowing-based waveforms designs, and we saw that for each proposed method there was some kind of limitation, because most of them are still suffering from a huge out-of-band emission, a lot of peak to average power ratio, a lot of problems, adjacent channel leakage ratio. So in our design, we tried to combine two windows of these like well-known windows to reduce the out-of-band emission, to reduce the adjacent channel leakage ratio, and to achieve better spectral efficiency, as we will see. For the research gap, as we said, we are trying to reduce the out-of-band emission by using the filtering and windowing and the combined window, as we will see. This is the suggested system, and of course there are more details in the paper. First of all, we are studying the 5G waveforms, which is like cyclic prefix OFDM and the universal filter multi-carrier. Then we propose a method of combining two windows, the windowing method. Then we are handling this in the time domain and the frequency domain. We are using also the Hanning windows, the Kaiser windows, and then we combine two windows in our system, and we will derive our results and compare it with other well-known windowing systems. Of course, there are a lot of details in the paper, but eventually, after comparing our design, waveform design with the well-known ones, the Kaiser one and the Hanning one, our proposed window showed that it can achieve the same power spectral density or even better power spectral density while reducing the out-of-band emission compared with these well-known waveforms for different structures for the UFMC and the cyclic prefix OFDM, while using the 64 QAM and the 256 QAM. For the bit error rate, though, despite the huge advantage of the power spectral density, we saw that there is some limitation of the bit error rate of our design compared with the Kaiser windowing and Hanning windowing, where the bit error rate is a little bit worse than those systems, which is something that we will try to work on to improve in the future. So this is the bit error rate evaluation of also the universal filter multi-carrier and the cyclic prefix OFDM for 64 QAM. As a conclusion and future work, we saw that there has been a lot of suggestions for windowing and filtering waveform designs, and we tried to suggest a new one that can increase the power spectral density and improve the spectral efficiency of the system for 5G and 6G or like 5G and beyond. We use the machine learning or the neural networks to detect the best window for each scenario, and then we take this window and we compare it with the well-known designs that were previously suggested, and we saw that our system can achieve higher power spectral density, better spectral efficiency, lower out-of-band emission, but still there is some degradation in the bit error rate. So in our future work, we will try to implement more windowing schemes that can both improve the power spectral density and improve the bit error rate for the waveforms for the 5G and beyond. And these are some of the references that we used in our work, and that's it for my presentation. Thank you for listening, and I will be happy to receive any questions.
Thank you very much, Doctor. It was very interesting talk. And if anyone have a question, please ask. Actually, I have a one. So it's your. I just waiting someone to ask before. Anyway, it's very interesting. Actually, this work is really aligned with my interest. So now you, as you said, you employ some machine learning algorithm to discuss this problem. Is there any way if we need to generalize this approach to apply a range wide of problems?
Yeah, I think this can be done once you collect enough amount of data, training data. So after that, you can just generalize it, the same data that you collected for the channel realizations, the pilot, the adjacent channel leakage ratio, the out-of-band emission for different types of windows and filters. Then you can use that as a training data to train any kind of system in the future.
That sounds great. So this is anyone have a more question, please? Okay, this is the end of our workshop. It is the last paper presented by the doctors, and thank you for our audience. Thank you for the organization, organization. Thank you for participating. We really enjoy this workshop, and I hope you enjoy too. So I will conclude the workshop, and bye bye. Ria?
Yes, ma'am.
Yeah, we finished the workshop, and I'm not sure if you wanted to add anything or.
No, ma'am. This is it.
Yeah. Okay.
Will you send for us a certificate that we participate, Raya?
So the questions and everything will be answered by the people who are actually controlling all the people who are you already contact with.
Thank you.
Yes. Thank you everyone for joining us. The certificates will be given to you by 25th. And if you have any further query, you can contact the people who you're already in contact with. They'll resolve all the problems that you have.
Thank you.
Thank you.
Hello.
Yes, sir.
Hello.
Yes, sir. Is there some problem?